let's look at the primary trigonometric ratios. So it's known that there is a relationship between the three sides of a right-angled triangle and its angle. And what we know is that a larger angle will create a larger opposite side. So if this angle right here at B becomes larger, then this side length here, AC, will become larger as well with the growth in the angle. Okay? So this basic understanding results in something called the primary trigonometric ratios, which allows us to solve for exact angles and exact sides. So given the triangle on the right there, triangle ABC, we use theta, said theta, to indicate an angle in geometry. For angle B, or theta, so let's put a theta right there. So that's the symbol for theta. We call side B, so B is this side right here. Little b is the side opposite of angle B, and we call that side the opposite. And it's the opposite of B, because notice that it is across from B. We call side A, so this is right here, side A, little a, and again it's across from the large angle A. And we call that side adjacent to B. Okay, and adjacent means beside. And side C here is called the hypotenuse. So side C is right here, and notice that the hypotenuse is the side opposite the right angle. Okay. So for the trig ratios here, sine B is defined as opposite over hypotenuse. And cosine is defined as adjacent over hypotenuse. And tangent is defined as opposite over adjacent. So some have short formed this into SOHCAHTOA. So this is sine opposite over hypotenuse, cos equals adjacent over hypotenuse, and tan equals opposite over adjacent. So this is something you would memorize and keep close at hand and ready as you work on these triangles. So let's try this out with triangle ACT. Okay, so if we're looking at the sine value of angle T, so we're looking right here at angle T. This is our unknown angle. I'm going to draw a stick person right here, stick it over here, okay? And sine, remember that sine is defined as opposite. I'm going to short form that to opposite over hypotenuse. Remember that was the definition we used right up there. So the opposite to angle T is the side across from it, opposite, so that's 7 over the hypotenuse, which is the side across from the 90-degree angle, so that's 25. So sine of t is equal to 7 over 25. At this point, we're just going to leave the answer right there. That's the definition of sine t right here. Cos of t. So if you're looking at cos of t, again, we're going to draw a stick it right here. Okay, and cos is defined up here as adjacent over hypotenuse. So adjacent over hypotenuse. Adjacent to angle T is the side beside it right here. So it's 24. So it's 24 over the hypotenuse, which again is 25, because remember the hypotenuse is across from the 90-degree angle. Next one, tan of C. So notice that this one now is angle C. So we'll stick it over here. Okay. And tan is defined as opposite over adjacent. So we have opposite over adjacent. So the side opposite to angle C is this one right here, the 24. And the side adjacent to C is 7. So tan of C is equal to 24 over 7. Notice that in a triangle, if we have a triangle here, A, B, C, and the same triangle, A, B, C. Okay, and if we take the perspective of A, this side is the opposite because it's across from A. This side is the hypotenuse because it's across from the 90-degree angle. And this side is the adjacent because it's beside A. But these are the definitions of the side lengths from the perspective of A. Now, if we take the perspective of C, then this side is across from it, opposite. So this is opposite. This side is across from the 90-degree angle. So it's hypotenuse. And this side right here is beside angle C. So it's the adjacent. So notice that the side labels will change based on our perspective. What we will never do in this is we will never take the perspective of the 90-degree angle because then things just get too confusing. We don't actually have an opposite side because the opposite is a hypotenuse and then you have two adjacent sides. So we will never take the perspective of this angle right there. We will always stick it right there or stick it right there. But it's one of those two and only those two.